Welcome to IC Bits. We train and learn. For final revision, we cover some basic concepts and do some problems on motion in a straight line. Please visit us at our YouTube channel, follow the link, please subscribe and click on bell icon. We upload new videos in this channel. As we upload, you get notifications. We look into some examples. A woman starts from her home at 9 a.m., walks with a speed of 5 km per hour on a straight road to her office 2.5 kilometers away, stays at the office up to 5 p.m., returns home by auto with a speed of 25 km per hour. Choose suitable scales and plot xt graph of her motion. Here is the data. She starts at 9 a.m. and she walks with the speed 5 km per hour at a distance of 2.5 kilometers, and time taken by walk will come distance by speed. We know the speed and we know the distance from her home to office, 2.5 by 5, which we get 0.5 hours, which is nothing but 30 minutes. By 9:30 she reaches office and she stays until 5 p.m. in the office, and then she takes auto to come home, and time taken by auto to reach home is, the auto speed is 25 km per hour, the distance is 2.5 kilometers, distance by speed with which we get 0.1 hour time, which is nothing but 6 minutes. That means by 6 p.m. she will be at home. From 9 a.m. to 5 p.m. 8 hours, and then the extra 6 minutes, if you add it, 8 hours 6 minutes. The motion of the woman is 8.6 minutes with for the distance 2.5 kilometers. If you take, that is the scale, if you plot the graph, we get this way. So I have taken the units, distance is here and time is here, 0 to 8 point, actually 0 to 8.06. The scale had not come yet. So when the time is 0 hour at this 0 distance, she started by walk with a speed of 5 km per hour, and she reached her office, which is 2.5 kilometers away from home, in 0.5 hours, which is 30 minutes. By 9:30 she reaches office, and then she stays in the office until 5 o'clock, which is in hours from 0 to we take the scale like that. If that is 8 hour, until 8 hours she stays at the office. After 8 hours she takes auto and comes home. The auto speed is 25 km per hour. The auto travels at the same distance, 2.5 kilometers, and it took 0.1 hour, which is 6 minutes. In 6 minutes she reaches home. That is the motion of the woman. So this is how we calculate we'll be knowing the measurements of distances and the time taken with a particular speed. So like this we keep Look at the example. A jet plane traveling at the speed of 500 km per hour ejects its production of combustion at the speed of 500 km per hour. The relative to the jet plane. What is the speed of the latter with respect to the observer on the ground? The speed of the jet plane after it is started ejecting the combustion is simply add the speed of the jet and the speed of the combustion products relative to the jet plane. That means 500 km per hour, 500 km per hour, simply add them, we get 1000. Because they are moving in the same direction, we can simply add the velocities. That is how we get the speed of the jet. Another example, a car moving along a straight highway with a speed of 126 km per hour is brought to stop within a distance of 200 meters. What is the retardation of the car and how long does it take for the car to stop? Assume the retardation of the car is uniform. Here is the data. We have initial speed, which is 126 km per hour was set. We now convert that into meters per second by simply multiplying 1000 by 3600. That will be simplified as 5 by 18. We multiply 126 with 5 by 18. We get 35 meters per second. Since car brought to rest, there is no final velocity, which is 0. The distance it traveled before it stopped is 200 meters. Now we need to know the acceleration or retardation. The formula we need to recall because we don't have time here. So the formula which we need to recall, the one which has only these inputs and without time also. So v square is equal to u square plus 2as. V square is the final, v is the final velocity, u is the initial velocity, a is the retardation or acceleration we are going to calculate, s is the distance. Substituting all the values in the table, we get a negative value which we are considering negative acceleration or retardation. We got minus 3.0625 meters per second square. Taken another data with u is equal to 35 meters per second. V is, we know, is 0. Retardation we have known, minus 3.0625 meters per second square. We need to know how long does it take for the car to stop. Now we need time. For this we need to recall this equation. The equation which has time and have all the other inputs. Here we don't require distance. So we need to recall this equation for at this time. V is equal to u plus at. V is the final velocity, u is the initial velocity, a is the retardation or negative acceleration, t is the time. We need to know the time. T is equal to, substitute all values in it and we get t is equal to approximately 11.42 seconds. Another problem. Two trains A and B of length 400 meters each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction with A ahead of B. The driver B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just moves past the driver of A, what was the original distance between them? Look at the picture. There are two trains are on parallel tracks. Their uniform speed is 72 km per hour. They are in the same direction, but A is ahead of B. Sometime later, the B decides to overtake A and accelerates by 1 meter per second square. After 50 seconds, the train A passes train B. If you know the relative velocity of train B with respect to train A, we will be knowing the initial velocity of train B. Anyway, we know time and acceleration of the train B, and we will find final velocity with this by using the equation V is equal to U plus AT. Once we get the final velocity, with this velocity the train B passes train A. So all we need to know what is the original distance between them. When we know the speed and time, we can now know the distance. Distance is equal to speed into time. That is how we solve the problem. Here is the data. The speed of train A is 72 meter per second. Speed of train B also 72 meter per second. In order to get relative speed, we subtract their speeds. Since they are in same direction, so we subtract their speeds. 72 minus 72 is 0. This we take as an initial velocity of train B. In order to overcome train A, B accelerated 1 meter per second square in 50 seconds. It overcome A. When we know initial velocity and acceleration and time, we should recall the equation V is equal to U plus AT. Because we should know the final velocity of B, so that we will be knowing distance, because the velocity into time we get distance. With the time speed and time we get distance. Here the final velocity is equal to initial velocity plus AT. Initial velocity is 0 and acceleration of train B to overcome A is 1 meter per second square, and the time it took to overcome A is 50 seconds. We get 50 meters per second. The final velocity it acquired is 50 meters per second to overcome train A. Since we know the speed of train B and the time it taken to cross train A, 50 into 50, we get 2500. We get the distance between the trains. The original distance between the train A and train B was 2500 meters. Thanks for watching. Please like, share, subscribe and click on bell icon and comment. Thank you. Stay tuned to next session.